Today we will talk about the Industrial IoT Platform by GWS Software, a powerful enterprise-grade system for digitalization and production management in various industries, providing tools for implementing optimization scenarios using artificial intelligence technologies, advanced analytics, industrial Internet of Things, and cloud solutions. We will talk a bit about the architecture of the platform to get a basic idea, as well as its potential applications and general positioning. We will also demonstrate how to visualize industrial data, talk about possible use cases and the benefits of using the platform in comparison with alternative approaches. Technically, the platform is developed using principles of microservice architecture, and its services are divided into 5 functional groups. First group is data collection and storage services. Second group is structuring and data processing services. Third group is UI services. Next group, administration services. And the last group is deployment and development management. Let's talk more about each functional group. First functional group is data collection and storage services. As a rule, the first task that needs to be solved in the client's environment is to collect information from different data sources, usually located in an industrial network, then store this information in a single format and provide unified access mechanisms to it. Data collection is carried out using collectors, which are an ETL, extract, transform, load, tool. The data collection collector extracts information from the source, converts it to a format appropriate for the storage at the platform, and publishes it to a databus. After that, the data is transferred from the bus to one of the platform storages. The platform supports 3 types of data storages: relational, time series, and unstructured databases. Universal Data Access Services act as a data provider for both users within the platform and external customers. So-called Universal Data Layer (UDL) services provide consumers with a single API for working with data from different sources, whose own APIs may differ. Next functional group is services for structuring and processing data. Designed to structure data, endowing them with additional semantics so that business users or application developers can have better access to it. Here one also can perform actions such as generating regulatory and reference information, events and data marts for further visualization or for the operation of applications that these data marts consume. Programmable and customizable calculations. The platform supports 2 types of calculations. Custom calculations are available to the user. It does not require any special programming knowledge to write a corresponding mathematical expression. Programmable calculations are available only to the programmer role. Work processes. Created for business process modeling and for mapping internal processes on the client side. The service is based on the integration of Communda into the platform. Object model. The object model service is designed to create models that allow describing complex hierarchical objects, structure of real technological or production processes that constitute the overall system, as well as its properties and relationships with other objects. The object model uses the approach described in the international standard ISA 95. Model objects are collections of properties. Thus, object model can help you create real digital twins of very complex physical objects or technological objects. So, object model is especially effective if you are trying to organize the collection and storage of structured data with a very large amount of data. Object model properties can have different data sources, real-time databases, static values, calculation formulas, and discrete sets, reference books. The object model service performs the following functions: creating, editing, deleting an object model, and setting up rules for controlling the values of model objects. The object model is divided into resource models and activity models. Resource models describe the hierarchy of the plant and equipment that is used in the process and divided into 4 types: physical asset model, equipment, personnel, and material models. Activity transactional models. Activity models are necessary in order to describe what operations can take place in production and what resources are needed to carry out these operations. This allows you to visually show what type this or that operation belongs to and how long it takes. Models of planned and actual indicators contain specific data on the plan and on the fact of operations. Reference materials. This is a service for managing regulatory and reference information, so-called Master Data Management Service. Events. The event service is designed to generate and store events that describe real technological periods in production. Events are typified and a separate event with its own set of attributes is generated for each type. For example, if equipment downtime occurs, then it is indicated which equipment failed or the reason for which this downtime occurred. Data marts. The purpose of the service is to reduce the workload from the database and prepare the data so that it can be conveniently used to build reports, dashboards, and applications. Next functional group is user interface, the tool for displaying data using different customizable formats. Applications portal technically is a site inside which other front-end services are located. UI wizard allows you to create a user interface. Allows you to place several previously created interfaces within one interface. For example, combine a mnemonic diagram and a dashboard on one screen. Mimics Designer acts for creating, editing, and viewing mnemonic diagrams on the portal. Mimic diagrams display current data. You can display instantaneous values, receive tag data, and analyze them. Report Designer allows to create the reports that work with historical data. Ready reports can be saved in various formats and sent by email. Reports can be generated at the request of the user and according to the set schedule. A relational database or a web service that provides data in JSON format is used as a data source for reports. Dashboard Designer allows to create dashboards, analytical panels that visualizes data, results, and indicators. Dashboards work with historical data and the interface is presented in the form of widgets that display the required information coming from the system. Next functional group is administration services. The main purpose of the User Permissions Management Service is to provide a specific user of the platform with the rights to perform the actions provided for by the role. In addition, the service is designed to restrict access to performing certain operations and obtaining information that is not intended for the user's role. The authorization service receives a request to provide access of a certain level for a specific user, and after processing it, allows or denies access. The security service only stores rules and security policies. Performance monitoring is the process of observing how the platform, as well as infrastructure components, are performing using logs and metrics. Platform management. With the help of the K8 orchestrator, the resources of the system are distributed depending on the need for these resources provided by a particular service. Infrastructure management is management of open source components. Licensing service manages licenses. Notification management. When changing, deleting, or creating events, the notification service sends email, SMS, intraportal notifications to configured user groups or a specific user. The last functional group is development and deployment, whose functions primarily include various deployment automation tools. There also are a number of tools available that allow performing code analysis, testing, and optimization. Continuous integration is a process. When a software solution is created, it goes through the following path before its creation. Writing code, testing, a Docker container is formed, the part that we transfer to the client. This whole path is a continuum integration. Continuous deployment is the delivery of ready-made sets of Docker images to clients. The purpose of these processes is to shape the solution and deliver it to the customer. Test instruments are an integral part of the build pipeline. The following testing tools are used: integration, automatic, manual, stress testing, testing with special tools. API standardization. All API interfaces that are in the system adhere to a certain standard. The platform is built on the RESTful concept, so all interaction between front-end and back-end services is done using HTTP requests. The data transfer is carried out and the data is transferred in JSON format. Since the platform has a microservice architecture, each service has its own API, The services interact through this interface with each other and with external systems. Development framework. The platform allows you to create your own custom applications and services. For this, it fully provides access to the necessary data. The data is complete, structured, and not contradictory. Containerization. Containers are installed on top of a physical server and its operation system Linux. Each container separates its contents from the operating system. The code is placed in a container, and this container has methods for interacting with other systems. It can be deployed on systems Kubernetes, OKD, OpenShift. In the next video, we will show you how to work with some of these services using a practical case.